Welcome back to linear algebra. Let's go. Jumping into Anki to begin with. 5 flashcards. What is the transpose of an MXN matrix A and how is it denoted? Transpose is essentially where you switch the rows for the columns and the columns for the rows. Columns for the rows, rows for the columns. It's denoted by matrix A to the power of capital T. What is another name for the variables in the linear system? Unknowns. Yep. What is the trace of a square matrix and how is it denoted? It's the sum of the entries in the main diagonal. It's denoted by TR and then the matrix in parentheses. Good. What is a pivot column in a matrix? It's a column that contains a pivot position. What is the entry in row I in column J of transpose of A if A equals? What is the entry in row I in column of J of a transpose of A? Okay, you're just gonna switch the A. It's A IJ right now, but it's gonna be AJI. Yeah. All right. Good. Nice. Okay. So let's go ahead and get my work from yesterday. Oh, and I'm going to grade what I did yesterday, and then I'll be back to discuss it. All right, solid polynomial, matrix polynomial, got that right, and then the row operation one, got that right. So we're going to jump back into more practice problems, and I'll be back in a bit to recall. All right. I completed 2 problems. This first one was basically trying to find values of A, B, C, D, in which A commutes with B, all the values of A, B, C, and D. And we found that A equals D, and they can equal any number between any value between negative infinity and infinity. C has to be equal to 0, and then D can be B can be anything between negative infinity and infinity. And then we kind of tried to write a parametric equation for it, but I just kind of ended up going with this as my final answer. Then for 25, we were solving these. We're basically solving this little system of equations. For whatever reason, we want to do this really roundabout matrix inversion way instead of just doing like subtraction or substitution or solving with an augmented matrix. We're going to solve this thing with a matrix inversion. So we convert it into matrices. Then we essentially eliminate this side with a matrix inversion and then multiply this side by it. And then end up solving for x1 and x2. So that's basically it. Tomorrow we're going to be doing some more matrix polynomial stuff. It makes me think, I've spent so much time in this book already, and we're only on page like 50. It makes me think if I'm going too slow, I shouldn't be going faster, but it is what it is. At some point I'll probably take linear algebra in school. I think school might be the best option just because with my learning system and my optimization, prioritization, I can do really well and learn everything the class is trying to teach while having some structure other than just like, learn this at your own pace, which I guess learning at my own pace will probably learn it deeper. So maybe it will pay off in the end. It probably will. But that's it for today. I'll talk to you tomorrow. See ya.